Good afternoon, guys. This is another program on MathCAD to show you how to uh, switch succeeding rows of a matrix when a zero value is encountered along the diagonal. Okay, so this is very useful to avoid any misbehavior on the process of eliminating. Okay, um, matrix coefficients using Gaussian elimination technique. And I have here a sample of a matrix A wherein this augmented matrix has actually a zero value at the diagonal. No? So if we do the Gaussian elimination technique straightforwardly in this particular problem, we will be uh, experiencing a division by zero since the multiplier is actually defined in terms of the ratio between your Aij all over Ajj. Okay, so wherein Aij is actually the succeeding row upon which the pivot, okay, is uh, reckoned from, and Ajj is actually the diagonal. The diagonal. So if this happens to reach the second row and the second column, and this is zero, so there will be a division by zero here. Okay, so a division by zero will actually yield an overflow in terms of uh, your computation. So I did not make use of an algorithm, so I just directly uh, use a program in MathCAD, uh, using a for loop again and an if statement. So here I use a conditional if statement to test whether the value on the diagonal is zero or not. Okay. So again, we start with the definition of the counter I and j, where I and j are simply the rows and the columns, okay, starting from 1 to n. Okay, so the number of rows here is actually starts from 1 to 3, so since n is equal to 3, but the number of columns, since this is an augmented matrix, will actually be in the range from 1 to n plus 1, which is 4, okay, in this case. So after defining the two range counters, so we now make use of a test a statement or a conditional statement testing the value of the diagonal, meaning to say that if you encounter a diagonal um, the diagonal cell, okay, defined within the matrix A, for which of course I is equal to j, and that value happens to be 0, so this is an end condition, so this must be satisfied both. Okay, so if I is equal to j, and meaning to say the location is on the diagonal uh, uh, part of the coefficient matrix, and the value is 0, then this must be performed. So the routine for such will of course involve another counter k, which will restore back, no, the counter to 1. Okay, so since we cannot use uh, the I or the J counter, we have to shift it back to 1 by using another counter K, and restoring it back to 1 makes another loop which will be defining k now as your new row counter. So this becomes now your row counter, sorry, your column counter rather, and your I will still be your row counter. Okay, so SIK now is again another temporary storage that will accommodate first the value of the succeeding row. The second row reckoned from the pivot where the value of the pivot is 0. Okay, so I plus 1 here refers now to your row 3. Okay, so this row 3 will all be placed into a temporary storage, okay, which is S, before we put the value of the third row in terms of the second row. So we cannot directly overwrite without putting it into a temporary storage, or else we will be losing the values and we cannot retrieve it later. No? So what we do is first we put it in a temporary storage, then we go back and set your row 2 to take the place of row 3, and then the row 3 now will actually be taking the place of row 2 by simply getting it from the temporary storage S. Okay, so that is the routine on this loop K. So we overwrite the second row by the first and overwrite the first row by the second by simply using a temporary storage. Okay, so then of course we have to return it back into a new matrix B. Since A here is defined globally, we have to define it again in terms of global scenario, and you can see that the final outcome for B now will give you a matrix in which these two rows were switched in terms of their row position. So take note that the first row is referred to the row where the diagonal is 0, but not the row defining the counter I. So I hope you have learned from this simple program on how to switch rows using a programming loop, for loop in the MathCAD platform. Thank you very much for listening and have a nice day.